Hey everyone, today I'm going to go over the basics of Motion Studio, starting with installation and connecting hardware, then on to drive configuration, test runs, and PR mode functions. If you didn't know, Motion Studio is free software provided by Leadshine and StepperOnline for tuning and monitoring servo and stepper products. If you don't have the hardware, there's an offline mode that lets you explore some of the features. This is pretty limited, so don't expect too much. It only supports RS-232, so the main use case is tuning and debugging a single access. It includes an RS-485 serial port tool, so you can monitor the drive while sending RS-485 commands. The first thing to do is download Motion Studio. There are a confusing amount of versions available. Some are specific to drive models. To get the best version, go to your device's info page and then click on the Download tab. Today I'm using a 1.4.10 beta from StepperOnline. I found this 2.2 version with an updated UI and a new PR mode feature for looping individual paths. Hopefully some of the features will trickle down. Before we can run the program, we need to connect the PC to the drive with a USB to RS-232 cable. StepperOnline and Leadshine typically provide debug cables with a female DB9 end, so we need to get a USB to RS-230 cable with a male DB9 end. If you run into any problems, having indicator lights on the cable is incredibly beneficial. Seeing whether you're transmitting and not receiving, for example, really can help diagnose any problems. I'd stay away from combination cables like this one that does both RS-232 and RS-485. Typically, they don't follow the standard paint mapping. Active pins can do some damage, so be careful and keep the power off until all cables are connected. Installation is just a matter of extracting the downloaded file and running the Motion Studio executable. The default language is Chinese, so the first thing I need to do is switch it to English. To connect, hit the wire icon, select the COM port of your cable, and then click Connect. It will negotiate the handshake automatically, briefly display info of the connected device, and then automatically close the window. To open the window and read all the details, just click on the Connect icon again. The options in the left pane will change depending on the device you're connecting, so it's possible yours will be different. Today, I'm using a little integrated closed-loop stepper motor. Under Configuration, there are settings for I/O and parameters. This drive has 7 assignable inputs and 3 outputs. Both the function and polarity can be configured. This driver came with input 1 as the enable, normally closed, which reads as on until pulled high. If you're working with a microcontroller, connecting the limit switches directly to the driver really increases the resiliency of your machine by eliminating coding interrupts or polling tasks. Click OK to save the changes. You'll get a rather confusing message. Assuming you want to persist the changes and click Yes, the message box just closes. Nothing appears to happen, but it's saved. Clicking OK again produces the same message, so you need to click Cancel to exit. Configuring outputs is the same. Changing parameters is fairly straightforward. It follows the same 3-step process as other manufacturers. First, you make the changes. Second, you write them to the driver. If at this point the driver starts, the changes would be lost. To persist the changes permanently, after writing to the driver, you need to follow the 3rd step and save them to the driver. This is important because some changes, like electronic gearing, will not take effect until after the drive restarts. And this is a serious failure for Motion Studio. There's no warning or messaging for parameters that require the drive to be restarted versus the ones that take effect immediately. And from what I can tell, the data structure for parameters doesn't even have a field to track this information, meaning it would be extremely difficult to script or automate parameter modification. I certainly could be wrong here, but I just don't see it in the included access database. The trial run is a quick way to validate connections and motor direction. Make sure the motor is enabled by hitting the Enable button. If the motor cannot be enabled, you need to make sure that there's nothing setting it off by default, possibly in the I/O panel. Then click the forward button to move the motor. It runs only while holding the button down. Click the position 1 button to record the current position. At the bottom, you can enter the number of cycles to run. Clicking on Run will move the motor from position 1 to position 2, the number of cycles specified. Changes here take effect immediately and do not require writing to the driver. There's a little message that says to press Enter to make the change. This is actually very important. You can make changes to fields that don't take effect until hitting enter or sometimes deselecting into another field. It's a good place to test out different speeds. The acceleration is given as how many milliseconds it takes to reach 1000 RPM, so the larger the number, the slower the rate. In the navigation pane under Motion, we can open PR mode configuration options. The first tab includes parameters for control and homing. The Path Parameters tab allows you to configure 16 path segments. Each segment can specify a type, position, velocity, acceleration, deceleration, and pause time. The type or mode can be position, velocity, homing, or e-stop. The command can be absolute or relative. Each path can also be configured to jump to another path when complete. There's a legend at the bottom for reference. Here I've configured a few segments for absolute positioning. It's set up to go from path 0, jump to 1, which jumps to 2, jumps to 3, which jumps back to 0 for an endless loop. But I'm going to shorten this just to have path 1 jump straight back to 0. After writing the parameters to the driver, we can go to the Manual tab, which is divided into 3 sections. The top section, for motion operation, lets you configure and run a single path segment. The middle section is for homing. You can hit refresh to see the current position information. The stop button will stop any running operation on the motor. The homing button will launch your homing configuration. And manual homing sets the current position to home or 0. The bottom section is for launching any of the 16 path segments. However, hitting 0 here has no effect. The best way I understand this is current control is set to trigger, which means it's sent for the inputs. So after deselecting trigger, writing the changes, we can hit 0, and path 0 will run as configured, jumping to 1, back to 0 endlessly. After stopping, refresh updates the position, manual homing zeroes it out, and do another refresh just to validate. Just for something slightly more interesting, I'll change it back to have the paths jump from 0 to 1 to 2 to 3 and then back to 0. We'll have the velocity and position be equal. However, path 2 will have a slower deceleration and path 3 will have a slower acceleration. This is a quirk on the interface. I changed path 3's velocity to 1500 and hit enter. However, the field remains selected. After writing and then reading, the change is wiped out. So in order to make the change stick, you actually have to select into another field. With the changes made and written to the driver, the motion is a little more interesting. Finally, I'll enable the trigger and then go over to the I/O panel to have an input turn the path on and off by changing the polarity. The state monitor opens to a live view of your drive. There's 2 categories for the monitor, quick and general. The only difference is their update times, which are adjustable in the config tab. Right-click on any values you want to add, remove, or change the category of. There are a lot of options for homing. Beyond just the method, homing has its own set of parameters for speed and acceleration. You can also include motion after homing is complete to add a buffer to any of the methods. Personally, I like torque homing. Torque homing has the motor move in a given direction basically until it detects a collision, and the collision is defined as some amount of torque for a given amount of time. So I often have homing configured to run every time the drive is powered on. It moves in reverse slowly until there's 50 milliseconds of 10% torque. It then moves forward about half a rotation and homing is complete. To me, it's a no-brainer to have the drive handle these operations. Coding a microcontroller that is probably going to be doing other tasks to do all this, only to then have to report back to the driver, it's just adding delays with no benefit. If you're still shopping, the NT series of drivers is interesting. They operate in closed or open loop mode. The software feels a little bit more comprehensive, includes a serial terminal, Modbus tools, motion and trajectory calculators for speed, acceleration, and distance. But it's also difficult to use. There's a lot of very odd error messages and sometimes a lack of error messages. For example, opening a serial connection is always successful, even if you don't have a COM port.